Hello everyone! How's it going? In today's video, we're going to cover 10 Python concepts that you should know. Use either single quotes, air quotes, or double quotes, air quotes. Strings are used to represent equals 11. Here, age is annotated with the type int, which means it is expected to store an integer value. Now, if we accidentally assign the wrong type of value, our code editor will usually show a warning. For example, if we write age, int equals, quote, 11, the editor will warn us that a string is being assigned to a variable that is supposed to be an integer. As programs grow larger and more complex, these warnings become very helpful. Programmers are bound to make mistakes eventually, whether because they are tired, distracted, or simply overlooked something. Type annotations help catch these mistakes early. Without type annotations, the editor would not know what type we intended to use, so it would not give us any warning. However, it is important to understand that type annotations do not affect how the program runs. Even if we define a variable as an integer and still assign it a string, the Python program will still run normally. Type annotations are mainly a tool to help developers write safer and more understandable code. A good way to think about type annotations is like a traffic light. When you are driving, a traffic light does not physically stop your car. It simply tells you when it is safe to go and when you should stop. You can still drive through an intersection when the light is red, but doing so might lead to problems. In the same way, type annotations do not prevent mistakes, but they warn you. Next concept, constants. Moving on to constants. In Python, there's no strict built-in way to create constants like in some other programming languages. However, developers usually follow certain conventions to represent constants. One common approach is to use type annotations along with uppercase variable names to indicate that a value should be treated as a constant. For example, we can import the final type from the typing module. From typing, import final. Now we can define a constant like this: version, final, bracket, string, bracket, equals, quote, 1.0. Here, version is written in uppercase to follow the constant naming convention. The annotation final, bracket, string indicates that this variable should not be reassigned. Even without the type annotation, developers often understand that uppercase variables represent constants. However, Python itself does not strictly prevent the value from being changed. For example, version equals 1.1. If we are using the final type annotation, the code editor this: show date, show date. No matter how many times we use this function, it always comes from the same source. So if we change the message inside the function, it will automatically function like this: print add 1, 2. The function will return the result 3. Specifying the return type is optional, but it makes the code safer and easier to understand. For example, if the function accidentally returns a string like return hello, the code editor will warn us that the return type is incorrect. If a function does not return anything and only performs an action, we can specify the return type as none. This tells other developers that the function is meant to run a task and does not created a class, but it would be more useful if the class could actually store information. This is where an initializer becomes important. An initializer is used to set up an instance of a class when an object is created. In Python, the initializer method is called dunder_init. It runs automatically whenever we create a new object from the class. For example, imagine we have a class that represents a car. Each car might have a color and a horsepower value. Class car def dunder_init self color string horsepower int arrow none. Self.color equals color. Self.horsepower equals horsepower. Here, color is a string that represents the car's color. Horsepower is an integer that represents the power of the car. The initializer returns none, which means it does not return any value. Inside the initializer, we use the self keyword to assign these values to the current instance of the class. Now we can create an object from this class. Volvo equals car red, 200. This is called instantiating the class, meaning we are creating an object using the blueprint defined by the class. Here, Volvo is an instance or object of the car class. We can access the attributes like this: print volvo.color, print volvo.horsepower. The output will show the color and horsepower of the Volvo car. Because the class is a blueprint, we can easily create many cars. For example, BMW equals car blue 240. Now we can print the details of the BMW car as well. Print bmw.color, print bmw.horsepower. Classes make it easier to create many objects that share the same structure and properties. Instead of writing separate code for every object, we simply reuse the class blueprint. Next, we will learn about methods. First, we remove the previous example and modify the class. Instead of color, we change the attribute to brand. For example, the brand for a Volvo car would simply be Volvo. Inside the class, we can define a function. A method is simply a function that is defined inside a class. Here, we create a method called drive, and it returns none. Inside this method, we print that the car's brand is driving. Def drive self none. Print fstring self.brand is driving. It is important to notice that we use the self keyword everywhere. The self keyword refers to the instance of the class. For example, if the object is Volvo, then self refers to the Volvo instance. If the object is BMW, then self refers to the BMW instance. So when we use self.brand, we are accessing the brand of that specific object. Next, we create another method called getInfo. Def getInfo self none. Print fstring self.brand with self.horsepower. Now our class contains attributes and methods. We can create an object like this: Volvo equals car Volvo 200. Then we can call the methods volvo.drive, volvo.getInfo. When we run the program, we will see that the Volvo is driving, and it will also display that the car is a Volvo with 200 horsepower. This works for any object created from the class. For example, BMW equals car BMW 240. Now we can call bmw.drive. The output will show that BMW is driving. Methods can also accept additional parameters. After the self keyword, anything we add becomes a normal parameter. For example, def getInfo self value int none. Print value self.brand with self.horsepower. Here, value is a parameter passed to the method. We do not use self for this variable because it is defined directly in the method parameters. Now, when we call the method, we must provide a value, volvo.getInfo10. The output will show 10 Volvo with 200 horsepower. This demonstrates how methods can use both class attributes and additional parameters. The final concept in this video is dunder methods. We will continue using our Volvo car object for this example. Right now, if we try to print the Volvo objects together and would raise an error. There are many other dunder methods available in Python. For example, there are methods for multiplication, comparison, and many other operations. By defining these methods inside a class, we can control how objects behave when used with different Python operations. And that brings us to the end of the video. These were 10 important Python concepts that every beginner should know. This video was only meant to be an introduction to these topics. I highly recommend that you study these concepts more deeply, do some additional research online, and watch other tutorials to fully understand how they work in real-world programs. However, this should give you a great starting point for understanding how Python concepts work. If you have any questions, feel free to let me know in the comments section below. Also, tell me if there are any concepts that you would like to see explained in more detail. With that being said, thank you for watching, and I'll see you in the next video.